Hello everyone and welcome back to the channel. I'm so happy to see you here today. Actually, before we start, I have a little story. Recently, I got a message on my WhatsApp line from one of you. You know the line I put in the description box. This student wrote to me and said, "Teacher, I understand the basic trigonometry, but when it comes to proving identities, or using the CAST rule, or those weight questions without tables, I get lost. Can you help?" So I told them, you know what? I'm not just going to send you a text back. I'm going to make a whole video for you. And here it is. This video is for that student, but it is also for all of you who might be struggling with the same things. If you find this helpful, please give it a like. It really helps us to reach more students who need this kind of support. If you're new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. And if you have any problems or topics you're struggling with, please comment down below. I read every single comment, and remember, for personal questions, my WhatsApp line is in the description box below. Feel free to message me there. I'm here to help you succeed. Today we are going to do an extra tutorial on trigonometry. This covers trigonometric identities, special angles, and the CAST rule. This lesson is suitable for SHS 1 and SHS 2 students, especially those preparing for WAEC. Now, I know that when you hear the words identities or CAST rule, you might feel a little nervous. Many students find this topic challenging because there are many formulas and rules to remember. But I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. I want this narration to be about 35 to 40 minutes long so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us start with part 1. Special angles. These angles appear frequently in WAEC exams. You're often told without using tables. This means you must memorize certain values. I know, memorization is not fun. I once tried to memorize the phone book just for fun. Kidding, please do not do that. But for these angles, you really need to know them. The angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. In radians, these are 0, pi over 6, pi over 4, pi over 3, and pi over 2. Let us look at sine theta. For 0 degrees, sine is 0. For 30 degrees, sine is 1/2. For 45 degrees, sine is square root of 2 over 2. For 60 degrees, sine is square root of 3 over 2. For 90 degrees, sine is 1. Here's a trick to remember sine. Write the numbers 0, 1, 2, 3, 4. Take the square root of each. Then divide by 2. Square root of 0 is 0. Over 2 is 0. Square root of 1 is 1. Over 2 is 1/2. Square root of 2 is root 2. Over 2 is root 2. Over 2. Square root of 3 is root 3. Over 2 is root 3 over 2. Square root of 4 is 2. Over 2 is 1. See, that pattern makes it easy. Now let us look at cosine theta. Cosine is the reverse of sine. For 0 degrees, cosine is 1. For 30 degrees, cosine is square root of 3 over 2. For 45 degrees, cosine is square root of 2 over 2. For 60 degrees, cosine is 1/2. For 90 degrees, cosine is 0. Just read the sine values backwards. Now let us look at tangent theta. Tangent is sine divided by cosine. For 0 degrees, 0 divided by 1 is 0. For 30 degrees, 1/2 divided by root 3 over 2. The halves cancel, so 1 over root 3. For 45 degrees, root 2 over 2 divided by root 2 over 2. They are the same, so it is 1. For 60 degrees, root 3 over 2 divided by 1/2. The halves cancel, so root 3. For 90 degrees, 1 divided by 0. This is undefined. You cannot divide by 0. There are also reciprocal values. Cosecant is 1 over sine, so for 30 degrees, 1 over 1/2 is 2. Secant is 1 over cosine. So for 60 degrees, 1 over 1/2 is 2. Cotangent is 1 over tangent. So for 30 degrees, 1 over root 3 is root 3. I want you to pause the video and write this table down. Put it on your wall. Look at it every morning. It will save you in the exam hall. Now let us move to part 2. Proof of trigonometric identities. Now, what is an identity? An identity is an equation that is true for all values of the variable. It is not like an equation where you solve for x. An identity is always true. We are going to look at the fundamental identities. Identity number 1. Sine squared theta plus cosine squared theta equals 1. This is the most famous identity in trigonometry. You must know this. How do we prove it? We use a right-angled triangle. Imagine a right-angled triangle. Let the opposite side be letter A. Let the adjacent side be letter B. Let the hypotenuse be letter C. Step 1. By Pythagoras' theorem. In a right-angled triangle, a squared plus b squared equals c squared u. Step 2. Divide both sides by c squared. We divide every term by c squared, so we get a squared over c squared plus b squared over c squared equals c squared over c squared. Step 3. Simplify. C squared over c squared is 1, so we have open bracket a over c, close bracket squared, plus open bracket b over c, close bracket squared equals 1. Step 4. Substitute trig ratios. We know that e over c is sine theta. We know that b over c is cosine theta. So we replace them. Sine squared theta plus cosine squared theta equals 1. Proof complete. I like to put a little check mark at the end to show we are done. Now let us look at identity number 2. 1 plus tangent squared theta equals secant squared theta. How do we prove this? We start with the first identity we just proved. Step 1. Start with sine squared theta plus cosine squared theta equals 1. Step 2. Divide both sides by cosine squared theta. This is the trick. We divide every term by cosine squared theta. So we get sine squared theta over cosine squared theta plus coan squared theta equals 1 over cosine squared theta equals 1 over cosine squared theta. Step 3. Simplify. Look at the first term. Sine over cosine is tangent. So sine squared over cosine squared is tangent squared theta. Look at the second term. Cosine squared over cosine squared cancels out to become 1. Look at the right side. 1 over cosine is secant. So 1 over cosine squared is secant squared theta. So we get tangent squared theta plus 1 equals secant squared theta. Proof complete. See how we just used algebra to transform the first identity into the second. Now let us look at identity number 3. 1 plus cotangent squared theta equals cosecant squared theta. This is very similar to the second one. Step 1. Start with sine squared theta plus cosine squared theta equals 1. Step 2. Divide both sides by sine squared theta. This time we divide by sine instead of cosine. So we get sine squared theta over sine squared theta plus cosine squared theta over sine squared theta equals 1 over sine squared theta. Step 3. Simplify. Look at the first term. Sine squared over sine squared cancels out to become 1. Look at the second term. Cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared theta. Look at the right side. 1 over sine is cosecant, so 1 over sine squared is cosecant squared theta. So we get 1 plus cotangent squared theta equals cosecant squared theta. Proof complete. Identity number 4. Tangent theta equals sine theta over cosine theta. Proof. Step 1. Write definitions. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Step 2. Divide sine theta by cosine theta. We get open bracket opposite over hypotenuse close bracket divided by open bracket adjacent over hypotenuse close brackets. Step 3. Simplify the fraction. When dividing fractions, we multiply by the reciprocal, so it becomes opposite over hypotenuse times hypotenuse over adjacent. The hypotenuse cancels out. We are left with opposite over adjacent. Step 4. Therefore, opposite over adjacent is tangent theta. So sine theta over cosine theta equals tangent theta. Proof complete. Please write these proofs down. They often come up in exam questions where you're asked to prove or derive them. Steps in your exam. Now, let us move to part 3, the CAST rule. This is where most students lose marks in WAEC. Pay attention. Imagine a Cartesian plane with an x-axis and a y-axis. This divides the plane into 4 quadrants. Quadrant 1 is from 0 to 90 degrees. Quadrant 2 is from 90 to 180 degrees. Quadrant 3 is from 180 to 270 degrees. Quadrant 4 is from 270 to 360 degrees. We use the CAST rule to remember which trigonometric ratio is positive in each quadrant. CAST is read anticlockwise starting from quadrant 4. C stands for cosine. In quadrant 4, cosine is positive. A stands for all. In quadrant 1, all ratios are positive, as stands for sine. In quadrant 2, sine is positive, stands for tangent. In quadrant 3, tangent is positive. Let me draw this out for you. Imagine I am drawing a big cross on the board here. Top right is quadrant 1, right A, all are positive. Top left is quadrant 2, right sine is positive. Bottom left is quadrant 3. Right T tangent is positive. Bottom right is quadrant 4. Right C cosine is positive. Another way to remember CAST is the sentence, all students take calculus, or maybe all students take coffee. All for quadrant 1, students for quadrant 2, sine. Take for quadrant 3, tangent. Coffee for quadrant 4, cosine. I do not know if you like coffee, but it helps you remember the signs. And honestly, after studying trigonometry, you might need the coffee. Here's the sine rule summary. In quadrant 1, sine is positive, cosine is positive, tangent is positive. In quadrant 2, sine is positive, cosine is negative, tangent is negative. In quadrant 3, sine is negative, cosine is negative, tangent is positive. In quadrant 4, sine is negative, cosine is positive, tangent is negative. The reciprocals follow the same sign as their primary ratio. Cosecant follows sine, secant follows cosine, cotangent follows tangent. Now let us look at how to find equivalent acute angles. When working with angles beyond 90 degrees, we find the reference angle and apply the CAST rule. In quadrant 1, the reference angle is just theta. The sine is positive. In quadrant 2, the reference angle is 180 degrees minus theta. The sine depends on the ratio. In quadrant 3, the reference angle is theta minus 180 degrees. The sine depends on the ratio. In quadrant 4, the reference angle is 360 degrees minus theta. The sine depends on the ratio. Now let us move to part 4. Practical application with WAEC style questions. Example 1, evaluating trig ratios in different quadrants. Question, evaluate sine 150 degrees without a calculator. Step 1, identify the quadrant. 150 degrees is in quadrant 2, that is between 90 and 180. Step 2, check CAST rule. In quadrant 2, the letter is S, so sine is positive. Step 3. Find the reference angle. In quadrant 2, we subtract from 180. 180 minus 150 equals 30 degrees. Step 4. Evaluate using special angle. So sine 150 degrees equals positive sine 30 degrees. From our table, sine 30 degrees is 1/2. So the answer is positive 1/2. Example 2, cosine in quadrant 3. Question: evaluate cosine 210 degrees without a calculator. Step 1. Identify the quadrant 210 degrees is in quadrant 3. That is between 180 and 270. Step 2. Check cast rule. In quadrant 3, the letter is T, so tangent is positive, but we have cosine, so cosine is negative. Step 3. Find the reference angle. In quadrant 3, we subtract 180 from the angle. 210 minus 180 equals 30 degrees. Step 4. Evaluate using special angle. So cosine 210 degrees equals negative cosine 30 degrees from our table. Cosine 30 degrees is square root of 3 over 2. So the answer is negative square root of 3 over 2. Example 3. Tangent in quadrant 4. Question: evaluate tangent 315 degrees without a calculator. EC style identity proof. This question appeared in WAEC 2021. The question is, prove that 1 minus sin A theta over cos theta equals cos theta over 1 plus sin A theta. Now, when you are asked to prove an identity, you usually start with the more complicated side. In this case, let us start with the left-hand side. Step 1. Start with the left-hand side. We write left-hand side equals 1 minus sin theta over cos theta. Step 2. Multiply numerator and denominator by 1 plus sin theta. You might ask, why do we do this? We do this because we see a 1 minus sin theta on the top. If we multiply it by 1 plus sin theta, we create a difference of 2 squares. This will help us simplify. So we write 1 minus sin theta over cosine theta multiplied by 1 plus sin theta over 1 plus sin theta. Step 3. Expand the numerator. On the top, we have 1 minus sin theta times 1 plus sin theta. This is a difference of 2 squares. It becomes 1 squared minus sin squared theta. On the bottom, we just keep cos theta times open bracket 1 plus sin theta close bracket. So now we have 1 minus sin squared theta over cos di theta times open bracket 1 plus sin theta close bracket. Step 4. Use the identity. Remember our fundamental identity. Sin squared theta plus cosine squared theta equals 1. If we rearrange that, 1 minus sin squared theta equals cosine squared theta. So we can replace the top part. The top becomes cos squared theta. So now we have cosine squared theta over cos theta times open bracket 1 plus sin theta close bracket. Step 5. Cancel cos theta. We have cos squared theta on the top. That is cosine theta times cosine theta. We have 1 cosine theta on the bottom. We can cancel 1 cos theta from the top and the bottom. We are left with cosine theta over 1 plus sin theta. This is exactly the right-hand side. Identity proven. Please write this proof down. It is a very common type of question in exams. Notice how we use the difference of 2 squares and the Pythagorean identity. Now let us move to example 5. Solving equations with the cast rule. This question is from WAEC 2020. The question is, solve for theta if cosine theta equals negative 1/2 and theta is between 0 degrees and 360 degrees. Step 1. Find the reference angle. First, ignore the negative sign. We just want to know what angle gives us 1/2. So we ask, cos alpha equals 1/2. What is alpha? From our special angles table, we know that cosine 60 degrees equals 1/2. So the reference angle alpha is 60 degrees. Step 2. Determine which quadrants have negative cosine. We are looking for where cos theta is negative. Look at our cast rule. Cosine is positive in quadrant 4. It is negative in quadrant 2 and quadrant 3. So our answers must be in quadrant 2 and quadrant 3. Step 3. Calculate angles in each quadrant. For quadrant 2, the formula is 180 degrees minus the reference angle. So theta equals 180 degrees minus 60 degrees. 180 minus 60 is 120 degrees. For quadrant 3, the formula is 180 degrees plus the reference angle. So theta equals 180 degrees plus 60 degrees. 180 plus 60 is 240 degrees. Answer: theta equals 120 degrees or theta equals 240 degrees. Always check the range given in the question. Here it was 0 to 360. So both answers are valid. Now, let us look at example 6. Combined identity with special angles. The question is, simplify without calculator. Sine a squared 60 degrees plus cos squared 30 degrees. Step 1. Recall special angle values from our table. Sine 60 degrees is square root of 3 over 2. Cos 30 degrees is also square root of 3 over 2. Step 2. Square each value. First term, sine squared 60 degrees. This is open bracket square root of 3 over 2 close bracket square. Square root of 3 squared is 3. 2 squared is 4. So this term is 3/4. Second term, cos squared 30 degrees. This is also open bracket square root of 3 over 2 close bracket squared. This is also 3/4. Step 3, add together. We have 3/4 plus 3/4. This equals 6/4. We can simplify this fraction. Divide top and bottom by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. So the answer is 3/2. Or as a decimal, 1.5. Answer: 3/2 or 1.5. See how knowing your special angles makes this very quick? Now let us move to part 5. Common WAEC. Traps and how to avoid them. I want you to pay close attention here. These are mistakes that cost students marks every year. Trap number 1, negative angles. Some students think that sine of negative 30 degrees equals sine 30 degrees. This is wrong. Sine is an odd function. The correct approach is sine of negative 30 degrees equals negative sine 30 degrees. Remember, negative angles go clockwise. Trap number 2, cast confusion. Some students think that chi's 150 degrees is positive. This is wrong. 150 degrees is in quadrant 2. In quadrant 2, only sine is positive, cosine is negative. So cosine 150 degrees is negative. Trap number 3, identity errors. Some students write sine theta squared as sine theta squared. This looks confusing. The correct way is to write sine squared theta. This means open bracket sine theta, close bracket squared. Always write it clearly so the examiner knows what you mean. Trap number 4, radians versus degrees. Some students use degrees in radian formulas. If your question has pi in it, you're likely in radians. Check your calculator mode. If it is in degree mode but you need radians, you will get the wrong answer. Trap number 5, undefined values. Some students think that tan 90 degrees equals 0. This is wrong. Tan 90 degrees is undefined. Why? Because tan is sine over cos. Cos 90 degrees is 0. You cannot divide by 0. So tan 90 degrees is undefined. Now let us move to part 6, practice questions. I want you to try these yourself. Pause the video and write down your answers. Question 1. Evaluate sine 120 degrees plus cos 240 degrees without calculator. Question 2. Prove that open bracket 1 minus cos squared theta close bracket, times secant squared theta equals tan squared theta. Question 3. Solve for theta. Tan theta equals -1, where theta is between 0 degrees and 360 degrees. Question 4. Simplify. Sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta. Question 5 is a challenge. If sine theta equals 3/5 and theta is in quadrant 2, find cosine theta and tan theta. Take your time. Do not rush. I will wait for you. Okay, let us look at the answers to practice questions in part 7. Answer 1. Sine 120 degrees plus cos 240 degrees. Sine 120 is in quadrant 2. Sine is positive, reference angle is 60. So sine a 60 degrees cos 240 is in quadrant 3, cos is negative. Reference angle is 60. So negative cos 60 degrees. Sine 60 is square root of 3 over 2. Cos 60 is 1/2. So we have square root of 3 over 2 minus 1/2. This equals open bracket square root of 3 minus 1 close bracket over 2. Answer 2. Prove that open bracket 1 minus cos squared theta close bracket times secant squared theta equals tangent squared theta. 1 minus cos squared theta is sine a squared theta. Secant squared theta is 1 over cos squared theta. So we have sine squared theta times 1 over cos a squared theta. This is sine squared theta over cos squared theta. And that equals tan squared theta. Proven. Answer 3. Tan theta equals -1. Tangent is negative in quadrants 2 and 4. Reference angle for tan 1 is 45 degrees. Quadrant 2, 180 minus 45 equals 135 degrees. Quadrant 4, 360 minus 45 equals 315 degrees. Answer. Theta equals 135 degrees and 315 degrees. Answer 4. Simplify sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta. Find a common denominator. It is sine theta times 1 plus cosine theta. Top becomes sine squared theta plus open bracket 1 plus cosine theta close bracket squared. Expand the bracket. 1 plus 2 cos theta plus cos squared theta. Add sine squared theta. Sine squared plus cosine squared is 1. So top is 1 plus 1 plus 2 cosine theta, which is 2 plus 2 cosine theta. Factor out 2. 2 times open bracket, 1 plus cos theta, close bracket. Cancel 1 plus cosine theta with the bottom. Left with 2 over sine theta, which is 2 cosecant theta. Answer 5. Sine theta equals 3/5. Quadrant 2. Cos squared theta equals 1 minus sine squared theta. 1 minus 9/25 is 16/25. Cos eta is -4/5 because it is quadrant 2. Tan theta is sine over cos. 3/5 divided by -4/5, which is -3/4. Answer, cos theta equals -4/5. Tan theta equals -3/4. Now, let us look at the summary cheat sheet. Here are the key points to remember. Special angles. Memorize 0, 30, 45, 60, 90 degrees values. Fundamental identity. Sine squared theta plus cosine squared theta equals 1. Cast rule. All students take calculus. All in 1, sine in 2, tan in 3, cos in 4. Reference angle. Quadrant 2 is 180 minus theta. Quadrant 3 is theta minus 180. Quadrant 4 is 360 minus theta. Proving identities. Work with one side. Use fundamental identities. Simplify. WAEC tips. Show all steps. State quadrants. Check signs with cast. Now, do you need more help? If you're still stuck on any part, 1. Reread this tutorial slowly. 2. Practice the examples with pen and paper. 3. Watch the quadrant diagram and trace the cast rule. 4. Message me on WhatsApp for one-on-one clarification. Remember, the line is in the description box below. Here's a WAEC exam tip for you. In the exam, always state which quadrant you are working in. Show your reference angle calculation. Indicate the sign plus or minus from the cast rule. Write special angle values from memory. Keep practicing. Trigonometry becomes easy once you master the cast rule and special angles. These topics appear in every WAE. See further maths paper. See you in the next tutorial. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you had any questions about this lesson, or if there is a specific problem you're stuck on, please comment down below. I try to answer as many as I can, and remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.